Hey TechEds, this is TechEd Kirsch, and in this video I'm going to show you how to do a circuit simulation in Altium Designer for inverting amplifier, just using an op-amp and some resistors. Now if you haven't seen my previous video where I evaluate the gain of the op-amp circuit, then you want to check that out. This circuit is based on that. And I just want to show you how to use Altium for circuit simulation. So if you don't have a project open in Altium, you want to go File, New Project. Then once you start a new project, save it wherever you want to. You go ahead and then add some schematic. You can add a schematic page to it. So you can right click on your project, choose Add New to Project Schematic. You save and name that schematic. See, I have basic simulation examples right here. And then you want to go to your Simulate tab. If you don't have the Simulate tab, you need to install the simulation option or feature under Extension and Updates. And then you'll be able to look for Mixed Signal Simulation. So mixed simulation here. Once you install that and restart your software, then you'll have access to the simulation. Okay, once that's done, go ahead and click Simulate, and then we're going to place some generic components. I like that Altium Designer has generic components. That means I could just, I don't have to find spice models to get something going. So let's choose a VSRC if you want just a voltage source. This voltage source has multiple features or functions. You can set this to DC source, sinusoidal, whatnot. I'm going to set this to sinusoidal because I want to see the amount of gain that my op-amp circuit will create. For the frequency, I'll set this to maybe 2 periods per second, so 2 Hertz. And let's see what else. I need some resistors. So I'm going to go back to my components section here on the panel that opens up. Okay. I also want my resistor, so I can just search for a resistor here and it'll pull that up. Hit tab and then you're able to set the resistance value before you place it. Not that that's even necessary, but that's fine. Here we got 2. Rotate with space bar on my keyboard. Hit tab while I'm placing. Set that to 8K. Tab again. And then I'll do this 3K and 9K. I'll just place these two and place another resistor over on this side. Zoom in with the middle mouse button. By pressing down the middle mouse button, I can zoom in. And then I want to place an operational amplifier. So under my components, I want op-amp. I just need to put OP and it'll start searching for me. I can go with, I think I'll go with this ideal one just to make it easy. And then this is the gain here. Right, I need to place a ground, so let's place some grounds on the circuit. Then I want to wire. So you can start wiring using this icon, place wire, or Control W as a shortcut. Alright, so yeah, just make these connections. As a best design practice, you don't want to have your wires making this kind of forward connection, like that. I don't know what it's called, but that junction, you want to avoid that. You want to make it very clear and explicit that you intended to make that connection. And that's just for any schematic that you create, whether you're simulating or not. Alright, let's continue wiring up this device. 2K. Oh, and I need to connect here to the non-inverting side of the op-amp. I'll make this a 3K resistor. Make this 9K. K meaning kilo, being short for kilo ohms, and then I'll wire this part. Okay. The next thing I want is to name the reference designators for these devices. So I'll go to, well, first of all, save, then tools, annotate schematics quietly, and hit yes. So now I have R1, R2 instead of question marks and all that. Now that I place my components, I can close the components window. I don't need the properties window here. And now I'll go to simulate, simulation dashboard. This is where it sets everything up. Let's see, empty circuit for simulation. Let me see here. I'm getting some type of error, probably because I had a prior simulation going. So let me correct this real quick. Alright, I closed the schematic and reopen it. Now start verification. Looking good. Electrical rule check. Simulation models. Check. It likes the simulation models. And then I have a V, like this is my V1 sinusoidal source. I'm going to add a probe. So the probe is like, an oscilloscope probe where I can check the voltage, and I'll place it on the output here. I'm also going to add a voltage probe on the input just so I see what that input signal looks like. The input signal, I'll set this to, well, actually, let me make sure I'm selecting the right probe. So if I click on VNet R1, that's this. Okay. That means, I think I want this to be like a really bright pink. For this V, I'll set this to like a deep blue. Or you know what? Let's set this to turquoise or whatever that is. Okay, that's looking good. I'll do my analysis, setup, and run. I only want this to run for 1 second, maybe 2 seconds. So I will choose my transient referring to time. You want to set your step size to about 1,000th of the time scale you care for. So let's say you want to run it for 1 nanosecond, then I would set it as a step size of 1 picosecond. Then you want to hit the run button specifically for that. And voila. Now I have the simulation showing that my amplifier gives me an inverting amplification. I'll use the left mouse button to drag this area so I can zoom in that way. You also have some other options, like if I just want to focus on one signal, I can click on the signal and it will focus on that. I can click on another signal to focus on it as well. Or I can select the same signal that I have highlighted, then it will deselect it for me, and therefore making all the other signals available. Okay, so we see that if we are at -1 or 1, doesn't matter, it will flip the polarity on the output and multiply it by 15. So this circuit has a gain of 15, or -15. And this verifies the calculations that we did earlier in the previous video. Okay, if you want to learn more Altium Designer, especially for schematic capture and printed circuit board design, then check out the next video where I start a new project and how you design your own printed circuit board.